is really focused on developer productivity, so how you can provide developer productivity with your platforms. And yeah, I already was introduced here, so my name is Timo Salm. I'm a senior lead Tanzu developer experience solution engineer, or in one word, pre-sales, and responsible for EMEA with a main focus on our commercial Spring product. So VMware is the vendor of Spring with the acquisition of Pivotal, where I'm also from, and the VMware Tanzu application platform, which is a fully integrated but modular platform on Kubernetes focused on developer productivity. And this is also why I talk about that stuff here. And I think most of you, they are familiar with Kubernetes, what it provides at the end, the benefits of it, like, for example, the improved resource utilization, or that it really enables a hybrid cloud model. That's one of the reasons why it's that popular, or more or less the infrastructure abstraction standard of today, because you have the same abstraction on the data center than on all clouds, and therefore you can create a platform in the same way and also deploy applications then in the same way. But at the end, it's like building a platform with Kubernetes is really complex. So Kubernetes is a tool to build a platform. It's not a platform at the end. And to build a platform, you have to choose from a lot of solutions that are available. And yeah, that's not easy because how can you compare them? So in best case, you have some requirements from your users and also some cost, whatever requirements regarding the solution. But at the end, it's like some of the solutions only differ in some tiny features, and you only find out after some time that maybe the other solution would be the better one. Therefore, a lot of also customers I'm talking with they really struggle in building a Kubernetes platform. And the main reason is usually that they don't have the expertise. So not only on the operator side, also on the developer side. That's a Kubernetes report from us, and so in the one for current year, so the biggest challenge is now that to meet the security and compliance requirements, but still the experience with Kubernetes there's not enough in the companies, and therefore it's really hard to build a successful platform. And with all those challenges, usually people tend to focus on those challenges and not to look around what's else there, and also it's sometimes hard to prioritize. And at the end, what we have as a framework or a methodology for that is we call it a platform as a product. So the focus is to really see your platform as a product with the same user-centric approach. And this is usually a lot of times in the IT world then missed. It's like, okay, we are building a platform. Someone said Kubernetes and containers. Let's do that and add as many tools available as possible. And then there are the first applications that have to be onboarded, and the developer is saying, sorry, I don't have those databases. I don't know how to build a container image. Other features are missing. The platform doesn't provide high availability, then I go to the public cloud because there I can just choose what I want. So that's the few of the developers, I would say. And at the end, to build a successful platform, it's really important that you have the requirements of the developers or the application to build it, and then also not that the team. So for sure, you build your platform based on those requirements and prioritize. But at the end, it's like you should really focus after you have the platform, for sure, improvements, adding new features to the platform, but also consulting, branding awareness of the platform. So if a developer says, hey, okay, I have that application and I need function as a service, and you are not able to provide to me, therefore I will go to the cloud. You should ask, okay, so, or should be able as an operator to ask, are you sure that function as a service is the right abstraction for your application? What is your application about? How many instances do you need? What are the scaling requirements, etc.? To then really do consulting, and maybe it's better to use another abstraction or the other way around. That developers are asking about, okay, I need a Kubernetes cluster to do what I want to do, but maybe a higher abstraction would be fulfill their requirements, and they can focus on what at the end, they are for building applications. They are not there to do anything in the infrastructure. And therefore, that mindset of platform and product is really focused on user-centric design of the platform and fulfilling all the needs of the developers so that they don't have to go to the cloud, or they don't care about where their application at the end runs. Just giving an abstraction where they say, here's my source code, deploy it for me, I don't care how and where. That's the story. And the problem with Kubernetes is everyone is going towards Kubernetes because of the abstraction it's providing, so that new abstraction standard. So every also huge applications from SAP, they will be modernized to run on Kubernetes. Everything will be on Kubernetes, but the problem is it's not for developers. At the end, it's like, it's a high abstraction compared to a bare metal or VMs. A higher abstraction, but it's not the abstraction that's really focused on developer productivity. And therefore, you have to build a platform that abstracts away all the infrastructure specific. So developers shouldn't care about a container image, because at the end, it's like, if you compare it to, let's say, the old waterfall world, where it was like software developers, they were assigned to a project, developed one iteration, and then they jumped to the next project, and just threw the code to the operators, and they were responsible for everything from the deployment to putting together that VM with all the different levels, so operating system to web server to whatever, and patching of that. Nowadays, it's like, because of the agile movement and the little bit misunderstood idea of the developers or application teams, they are responsible for the full life cycle of the application. It doesn't mean that they are responsible for the deployment. It means that they need tools to support them to ensure that application is running like it should be, with observability, for example, and that also the feedback that's coming from the end customers, that they can put it in the new iteration of the product to improve it. So the same mindset as for the platform, also for the application then. It doesn't mean that they should care about container images, because it's like, if you still deploy on VMs, that you would say to a developer, so here, please create your virtual machine image and choose WebSphere, whatever you want, and the OpenJDK version you want. That's not, or the distribution you want, that's not how it should be at the end. And therefore, we need tools on top of Kubernetes to provide that high abstraction to the developers. That the story is like in the waterfall days, but with a new agile setup where you try to reduce the risk, and developers can say, here's my source code, deploy it to me in production, I don't care how and where. And for those tools, so this is what in those minutes I have, I want to introduce to you some of the tools that help to provide a higher abstraction for developers on top of Kubernetes. Maybe some of those can be also then be helpful for you and for the experience you want to provide to your developers. And therefore, we have to build at the end a so-called app-aware platform. As said, so the abstraction is really about that. Okay, I have an application that is not in any way has to be built for a specific infrastructure. So an application then should be built like, okay, I don't care whether it's running in a container or a VM, whatever. That should be completely handled by the application platform. An example of an app-aware platform that exists for several years is, for example, Cloud Foundry, if you know that, where it was like you had that CF push, it was application code, and a lot of people that use it don't know that it's also using containers, but not Kubernetes as an orchestrator. It's using Diego as an orchestrator. So at the end, it's like, it does the same thing Kubernetes, but no one sees that it is a container platform. And the first thing usually it starts with where you can really see, okay, we are exposing infrastructures to the developers is if they are responsible to define a Docker file. Because then it's really, could be the same if you're on a VM platform, they say, okay, now build your VM image to deploy it. That doesn't make sense. So for sure, or the question is, why is it the case that it's nowadays usually in a lot of companies, the customers, that the developers have to define the Docker file. The reason is the flexibility in the technology, but you can also provide that with tools that detect, okay, it's Python, Spring, whatever. Yeah, that's the goal of the first open source tool I want to show you. And as you can see, for example, here, it's really easy to build a Docker file and then build a container image on the left side. So 4 lines of code, and I have a running Spring application in a container if I then deploy it. By the end, it's like on the right is the best practice Spring image. You can see it has a lot of additional features. So it starts with the choose, the selection of the JDK or Java runtime. Then it's using, for example, layered images that you reduce the size for your traffic at the end. So every time you are on a new node, for example, in a Kubernetes cluster, it has to pull down your image on every update. And if you reduce the size and have that layered images, or those layers for your images, and only the application code that changes frequently is one image, you save a lot of traffic and also disk space, for example. And the solution that exists for that for several years now are the build packs that are common to Cloud Foundry, and there's a new standard built together by Pivotal and Heroku some years ago that's called Cloud Native Build Packs. They are faster than the original build packs and more modular, for example. And what they provide at the end is really that experience. Here is my source code. And then so-called build packs will detect, okay, it's a Java source code, it's using Maven or Gradle, or it's a Python source code. And then they will automatically build a container image with best practices from, for example, our engineers in mind, and push it to a container registry. And to do that, so there's a variety of build packs available, also open source. For example, our open source build packs, they are from Pacato. And there's a pack CLI to build a container image, and also, for example, in Spring Boot, there is, since the version 2.3, build pack support available. So it's when you run Maven build image, you get a container image and can push it to a registry. For a real production deployment and on a Kubernetes cluster, we have a tool called Kpacks, which is Kubernetes native. It's using cloud native build packs to provide more or less the same story. Here's my source code, build a container image for me. It automatically pushes it, and it has one big advantage. It automates one big problem of every container image, and that's the update of the base image. So that's completely automated for all applications. So it's like, if you have, let's say, 1,000 applications that you push every few days in production, you need a container image for every of those. And then you have your Docker file, and if there is a CVE in one of the base images, all developers usually have to update that in a Git repository, and then a CI/CD pipeline will build the image and deploy it at the end. With Kpack, it's like that the operator, okay, there's a new base image, a new operating system image or build pack available. With one command, he patches this in the cluster, and every image for the current configuration will be automatically rebuilt immediately with that new base image. And then based on your process, it can be completely automated, directly pushed in a production or some pre-prod state where someone has to approve it. But then it's completely automated image-based updates, which is, regarding security, a huge factor. And as said, also developer productivity, because they don't have to care about that security aspect anymore, and also don't have to care about, okay, how do I have to build my container image at the end. The next thing is then really about how can I deploy my application. So I have a container image, I want to deploy it. The Kubernetes way is I have to create a deployment, a service, an ingress object maybe, define a lot of things and configurations from health readiness probes to things like graceful shutdown, etc. And to solve that, it's a good idea to have an abstraction on top of Kubernetes that solves some of the challenges for you. And in this case, we call it a serverless runtime, because usually what serverless is, you can group it in 2 areas. The first is backend as a service. It's really replacing server-side, self-managed components with off-the-shelf services. So everything SaaS service, for example, is typical backend as a service. If you have an application that's using some authorization, you can yeah, for sure implement it all your way or put it as part of your application in the source code, but you can also use something like Auth0, for example. That's then a typical packet as a service solution. So you don't need the people that manage it, you don't have to implement it, and at the end, usually it saves you a lot of costs. The second thing is function as a service. It's really about a new way to implement a software around functions, so really tiny bits that then are specialized on one aspect, and especially with AWS Lambda, they are really famous, where you then have a lot of scaling of those individual functions. And both is supported by Knative, that's the open source solution, where Red Hat, Google, VMware are the main contributors to. So it's a serverless runtime on Kubernetes. It's in higher abstraction, scale to zero capability, so you really have that AWS Lambda experience on any Kubernetes cluster. So also in the data center, which is great. And that's the serving part. The story is really like, here's my container image, and then you have an URL. So the ingress, for example, will also automatically configured for you. And the second part is eventing. That's about really enable event-driven architectures for developers. That's another component. They previously also had a build component, which is now called Canico, but Canico is also working with Docker files, just for your information. And so I will try, because of the fact that the speaker, so it's a little bit not optimized for me, but I will try to show you how easy it is to first build a container image. So for sure, because of the time, we cannot wait until it's ready, and also how to deploy it here as a demo. And for KPAC, we have a CLI, also that you don't have to use that much YAML. It's also possible, everything is Kubernetes native, to use YAML files. Also then, if you, for example, have that, or you are using GitOps or something like that to store the current state. And with a CLI for KPAC, it's called KP. It's really easy to create a container image out of a Git repository, and also then KP automatically watches whether there's a change in the Git repository and creates a new container image. So it also has some automation regarding the fetching and watching Git repositories. The developers can do git push, and then a new image will be built. And the command for that is just kb image save in this case. There's also one create, but save. I use that here now because I already have an image because of the time, and it just overrides the configuration. And you can see I just only have to define a name for the image, the Git repository where it is, and then the tag in the easiest configuration. So the tag is at the end where then my container image will be pushed to. And if I apply that, in this case it's already there. That's it, more or less. Then automatically a build will start by the first one, and on every git push also. And also as that, if there's a new base image available, the operator imports it, or with our commercial solution, it's also auto-update functionality. It will just fetch a new image every time there's one available. And then developers, or operators and developers don't have to care about security updates. And we can then, for example, have a look at the image. What's the status of it? In this case here, of my Hello World image, and you can see it there in the status. You can see which of the build packs, because they are really modular, those cloud-native build packs were used. So it was detected that, for example, Maven is used to build it. Then some Spring Boot build packs that do some special stuff about Spring Boot. You can see here that the JRE distribution that was used, so it's really like it's detecting all the different build packs, like for example also CR certificates, and then each of the build packs does something and adding something to a layer at the end, and then you have the build image. And also you see, okay, where the latest image is and the status. Here, for example, that the build reason is commit and config. And if I want to have a look at the builds, for example, I can just do a kp build logs command, and then I see all the build logs, and you can see the different steps, like prepare is okay, what's the source code I want to build, and then there's a detect phase where it detects, okay, based on the files that are in my Git repository, let's say the POM XML, oh, it's Maven, it detects the build packs that will participate in that image build, also for the runtime and the building, and then it will start building the application, to a jar file and putting it in at the end in those different layers, as you can see here. And yeah, that's it already for the image building. So it's really like one command, and you have more or less a pipeline for image building. And we can see as proof, so the container image is available here in my Harbor registry, and therefore it's ready to be used. So now, how would we deploy that in Kubernetes? We would start, maybe in the easiest, we would do something like kubectl run, and yeah, just deploy it as a pod or create a deployment. And then we have to also create a service and an ingress maybe. With Knative, there's also a CLI, but we can also just use the Kubernetes object if we want to. And the command is also really easy. So kn service create, the name, the image, and the namespace. And that's it for the most basic configuration, for sure. And then all the different components will be created for me. So from the deployment to the service with some opinions also to the ingress, and it waits until the ingress is ready, and then outputs directly the URL, and then I can run a curl and call it. So that's it. So this is how you can really easy with high abstraction deploy something on Kubernetes and directly expose it. For sure, if you have a setup that, for example, your ingress is only available internally, that also works, stuff like that, so setups of that Knative. And it's also like, it's not only, okay, now I have a URL and can call that application, it's also out-of-the-box scale to 0 capabilities, so without any additional configuration. This will scale to 0 instances. My application is not optimized for serverless, so it takes 3 seconds to start, and we can see that if I waited long enough, not yet, that it will just terminate that instance, and then if I call it, it will wait, and then we'll start an instance. For sure, you need applications that support it. So for example, with Spring, you should maybe compile it to a GRAL VM native image that you have milliseconds of a start time, then seconds. And then it's like you can, if there's demand, scale from 0 to 2,000 containers within seconds, if there is the traffic for that. And yeah, with that, let's now move on and have a look at the next feature I want to show you. So we have the deployment, we have container images. What's missing at the end is the integration, I would say, because currently it's like, okay, I had to manually put in the container image. And as you know, at the end it's like there are a lot of CI/CD tools available. So, and it's really hard to choose the right one because at the end it's like there's so many different available that all have some great features. And the problem with mostly all of them is that, for example, they are all synchronous. And usually it's like that all the tools you have in a CI/CD pipeline, some of them, they provide additional functionality that's asynchronous. And what you have to do is, usually they use orchestration, so you have one component that you have to trigger that then runs the CI/CD pipeline from the beginning. And yeah, so everything has to be compatible in a way with it, or the orchestrator has to be aware of events that are coming from all the solutions you have. A better solution and more natural for CI/CD is choreography, so asynchronously, that all the components are asynchronously connected via events. And then it's like, let's say, for example, KPAC, as we saw before, if there's an image update, KPAC automatically or will be triggered by the operator by an import command, or automatically with our commercial solution fetches the base image, and then container images will rebuild automatically. At the end, it's like if you have a synchronous or an orchestration solution, you in a way have to have that plug-in that the orchestrator knows about those events, and they will be sent to the orchestrator. With choreography, it's like the KPAC does whatever it does. And based on a status update of the CRT, for example, automatically an event will be via the orchestrator forwarded to all the components that are watching for it. So then it's like if you compare it to an asynchronous microservice application versus an asynchronous one, where it's just like, okay, if there's an event, I do something as a step. If not, there's not. And with that solution, we not only have that asynchronous functionality, we also, the idea is to have a reusable CI/CD, so every type of application goes to the same path to production. It's also something special, so not like, okay, we have a template, and if we update it, we have to find a way to update it everywhere. It's one way, the idea is to have one path to production for every web application, whether it's Spring, Python, whatever. For sure, all the tools you have in your path to production then have to support it. But for example, KPack, as said, it supports it because it doesn't. It has a lot of build packs available for all the typical technologies, and therefore it provides that polyglot capabilities. All the container stuff usually doesn't care that much about whether there's a Spring application running it or a Python application. So it's more about what is before the container building, like security scanning, etc. Those solutions also have to provide polyglot capabilities. Really important separation of concerns, because at the end it's like, who's currently responsible for it? Is DevOps, so DevOps is more a mindset than a role, but I know there are a lot of DevOps roles. DevOps people in a role of, because there's a need for it, because of the complexity of the path to production. And at the end, it's like, if you have a good separation of concern, which Kafka provides, so it has an interface for developers where they configure, here's my source code, I want to, if you have a functionality like this, it's also a standard created by Red Hat and us, service bindings, you can say I want to bind to that service automatically, and then those credentials will be put in the running container. It's really like source code, service, configuration, maybe some customizations and applied, and then you have a continuous path to production. So it provides an interface for developers called a workload, and then tools for operators to integrate all those Kubernetes resources. That's Cartographer, that's an open source project by us. And so to visualize that, this is how it looks at the end. You have a lot of developers, they are working workloads in different technologies. All of them will be applied in a so-called build cluster, for example. Then you have one supply chain for every web application. For sure, if maybe there's some differences in whatever, you can have multiple. The idea is to have as few as possible. And one big benefit is also that the operators, if they update the supply chain, it will be automatically directly be available for every of the workloads. So every next Git push, and also if you change something, directly all the application steps that changed, so or in the path to production will be updated and run immediately. So it's like that updating of supply chains is really easy. You just go to or apply to Kubernetes cluster or do it via GitOps, and you have the new path to production. And yeah, also for the deployment, and for example. I think I'm a little bit over time, so the last project you should have a look at is Backstage, because at the end you need something where developers can discover whether the application runs as it is, and also provide more capabilities like a centralized documentation of all the applications in your organization, because at the end, the most problem to solve in organizations is the integration of other APIs that are, for example, available systems. And if you have one central place where all that is available, it's really easy to integrate stuff. And also Backstage, what's special about it, you have one URL. And the idea is, instead of for every tool have another URL tab open, is that via plugins, they have plugins for all famous CI, CD, and tools you're used to use. And you have everything in one portal as a plugin system. So that's a solution open source by Spotify, which is also great. And yeah, that's it. So I showed you in those 30 minutes some of the open source projects we are using for our fully integrated platform. You can see there are a lot of more. And yeah. I hope what you learned is that you should focus more on developer productivity and ask your users of the platform, because then it can be successful, otherwise not. And that's also a big problem why all the developers are looking towards the cloud. Because for sure, for AI and whatever, there are great services to use, but for everything else, you are more or less able to provide the same experience in the data center. And then for them, yeah, they don't care about where it's running if they have the functionality to run their modern applications. That's it from my side. And one last note here. is that if you're interested in Lego, so not just building platforms, you can come to our booth and yeah, participate in our raffle and can win some Lego. Yeah, that's it. Thank you.
Thank you so much, Timo. And we do have time for questions. You were only 1 minute over time, so please relax.
Yeah, so I'm happy if you have any questions.
Yes, I think we have 2 questions, so here we go. The first is, does KPAC image building inside Kubernetes work? Oh, if only unprivileged pods are allowed.
At the end, that's the benefit of it, that it builds it in unprivileged containers. So.
Great, well, that was easy. Is there any software that can create a Helm chart automatically with dependence to programming language in use?
At the end, it's like Helm chart is also a deployment model developers shouldn't care about, summarized. So, and it really depends how you package your software then together and what's required for that. So, let's say, for example, for microservices, you have microservice application. Each of the microservices should be deployed independently, and therefore, Helm chart is in a way an anti-pattern, because you shouldn't package together what you split for developer productivity. And then also to bundle it together with databases. As said, there are solutions like, for example, that service binding capabilities, where it's like, for sure you need a self-service to provide those services, but then so it's more about the self-service to provide the stuff, and then you have those available in a cluster and bind to it automatically via service bindings. Then you don't have to really configure something in the application regarding credentials or that are environment specific, because it's like your services are via self-service deployed, for example, in a cluster, and you have that service binding functionality that's looking for, okay, that's the name of the service, and you can see what's available in the cluster, and it will automatically fetch those secrets or credentials for the service and put it via environment variables in a container. And with Spring, for example, it automatically also detects that type of secret, so there's a specification how it should look like, directly put it in the correct configuration properties, and therefore it's like for developers, they don't have to specify any credentials. It's like, in a lot of those dependencies, let's say a database, you don't have to configure anything. It's like I just put in the dependency, I create my JPA repository, and then because of the service bindings, you define in the workload that you want it, it's just there. You deploy it and it's connected to a database because it's injecting those credentials automatically.
Cool. There's a question that actually popped into my mind as well, so I'm glad it was asked. How does automated image building interact with GitOps deployment tooling like Flux? I saw Flux on your list of software that you use as well.
Yeah, we're also using Flux. At the end, for GitOps, we also have another tool called Carver Tools, just for information. It's also open source, so we're not earning any money with that. So therefore, I think it's fine to mention that. But at the end, it's like automated container building is about providing a container to a registry. So also, if you have GitOps, you need a way to provide that image in a registry to deploy it later. And therefore, it's more about the deployment YAML you have. And you can also, for example, with that cartographer solution, just have a step that pushes your code in a Git repository, and then have a solution like Flux or Argo CD that deploys the deployment YAML, but the repository is still in that registry you have. So it's like, at the end, the container is always in the registry, and it's more about the YAML files you produce. And for that KPAC Knative case, all the tools I showed the CLI, that it's easier to understand. But at the end, they are all YAMLs. So it's like then instead of a deployment, a service, and an ingress, it would be that you have the Knative CRD that you put in the Git repository, and then you have the GitOps functionalities, same as a deployment or whatever.
Great answer. I think we have time for one last question, which is, how would you balance abstraction of cloud-native technologies with the necessity to develop cloud-optimized applications?
At the end, it's like, the first question is, what do you want to optimize? Do you want to optimize costs? Do you optimize features? So that really depends on that. And it's like, there are always special cases. And there's also always like, okay, but someone for its application needs something very special. So as I said, an iService, etc. And I think it's all about providing that abstraction, that high abstraction as possible for the maturity of the users. And if there's something special, so also like, if you build a platform like that, you could also if they give different levels of abstraction. So you use Cartographer with a workload YAML as the highest abstraction. But if there is the use case that someone says, hey, but I'm happy to use KPack for image building, but because of something special, I'm not able to use Knative, for example. The default autoscaler of Knative is focused on traffic over HTTP, and if you have something asynchronously, then it's not able to scale because it doesn't have this autoscaler by default. And then you could say, okay, because of that, I'm not able to use Knative as an abstraction. Please provide me a solution that I can use a standard deployment and service. And you can do that via also an abstraction, or you can say, hey, okay, then you have cluster access, and you can just put those different solutions together as you like. So it's like just about providing always the highest abstraction possible. And then if there are special things, go down the abstraction that fits that use case.
If in doubt, abstract. Yeah. Okay, thank you so much, Timo. It was a wonderful presentation. Let's all give him a big round of applause, and then we'll have a 10-minute break. Thank you.
Thank you.